Hi, Catherine. I love seeing faces. If you're somewhere where you can turn on your camera, that would be phenomenal. I know our presenter would love to see all of your faces. But if your circumstances don't allow you to turn on your camera, things are hectic, you're just not feeling it. We understand that too. Just use the chat, utilize it, unmute yourself. Welcome, welcome, welcome. Charleston, South Carolina. Oh, Reading. Not too far from me, not too far. We're going to give it about another minute or two and we'll get started. Texas, you're on my list to go, okay? Dallas or Houston area or any other area because I'm terrible with that lay of the land. All right. Okay. So you experienced the best of both worlds, kind of? Is that appropriate to say? Does that make sense? Yes. Awesome. All right. While everyone is trickling in, I'm just going to start and kick it off. Hello, everyone. Good afternoon. I'm Jude Hussein, Communications Specialist at Foundations, Inc. I'm joined by my colleague, Paula, and we would like to thank each and every single one of you for being here and investing in yourself for your own professional learning. Before we start, I'd like to give a little bit of a background about Foundations, Inc. Foundations is a national education nonprofit located in Mount Laurel, New Jersey. Our mission is to improve the quality of education by building the skills of educators. We work across the school day with after-school programs, schools, districts, and states to create a brighter future for every child every day. If you are interested in learning more about Foundations, take a minute to follow us on social media and interact with us. I see Paula is dropping it in the chat. You may know us for our signature professional learning experience beyond school hours. Our conference is held each year in February where professionals, exhibitors across the nation attend for action-packed workshops, networking opportunities, and renowned keynote speakers. In this upcoming new year, we will be back in person in Orlando, and we would like for all of you guys to be our guests. Registration is open for the Beyond School Hours Conference, which will be February 23rd to the 26th. Once again, thank you so much for joining us today. We hope we'll see you next week for another Beyond School Hours follow-up webinar. It happens every Wednesday, same time, 3 p.m. Eastern. So please ensure that you RSVP. So without further ado, I'll stop there because you're not here for me. And I'll introduce the phenomenal founder and president of Mango Math, Mary Curry, and she'll kick us off.
Well, thank you so much for having me. I really appreciate being here, and I love having all of you guys here. Know that this is going to be a participatory activity. I'm hoping to have you guys participate either through the chat box or live visual camera because we want to get you all engaged in math and in particular problem solving. So a little bit about my background. I am an educator. I've taught elementary through middle school, actually all grades, because I have a degree in elementary ed as well as special ed. So I have worked with kids of all different ages and groups. And so I have done that. And then I have a master's degree in curriculum and instruction. And I had then made my own business, which involves mathematics and math writing. And I have done math writing for about 20 years now. So I have a lot of experience in mathematics, and we were just kind of talking earlier that I'm a big advocate of the fake it till you make it. So if you're not feeling confident in mathematics, know that just through a positive attitude, you can really bring kids along and get them to succeed in math. So with that being said, I am going to share my screen here. So you all are here to see problem solving in math and beyond. So we're going to be talking a lot about problem solving and how we can get kids engaged in real life problem solving situations where they can really blossom and grow in. So first off, let me get on here. In the chat box or visually, if I can, just a second, if you all could let me know where your level of math enthusiasm is. Are you A, you love it and you can do it visually by giving me a sign A, or if you are okay with it with a B visually or on the board, putting in a B. C, it makes you nervous, or D, you hate it. So be honest and let me know what your thoughts are with regards to math, so I kind of know where we're at here. So I see kind of people in lots of different levels. So B's and C's, probably the majority. Got a few love it, a few that hate, one that hated it, which is perfectly fine. Not all of us have had good experiences in math. So thank you for sharing where you are in mathematics, because that will help me in presenting to you. So know that kids also have all these different emotions in mathematics. Mathematics really is one of the subject matter that can cause the most stress in students. And they've done a lot of surveys that show that math can be a very stressful subject. So really the goal is to try to take that stress off, especially in today's environment in which their kids are coming back into school with a lot of stressors. We need to be able to present math in a format that is less stressful. So I am a huge advocate of getting kids off of worksheets and into group activities that help them explore mathematics. And that's what we're going to do today. So going back into this, so the importance of problem solving. So it's not just, I want to clarify the difference between problem solving and story problems. So we'll kind of bring up story problems a little bit, but the idea is this bigger avenue of problem solving. Kids can take that and apply it to different things. So, and the importance of it is in math, your primary mathematics is really problem solving and reasoning. And it's really not the memorization of algorithms or the algorithms themselves. It's really about reasoning and problem solving. It allows students through these problems to solving activities to really develop a deeper understanding of numbers and how math is used. And in particular, real world context, because when they're talking together, they're going to be communicating mathematically, but trying to solve problems that are kind of a little bit different than that. And it allows students to explain their process. When they're problem solving in a group activity, they are going to be explaining their process and their thinking. And then it's transferable to other subject matters. So they did a study in which they showed that the more math that kindergartners did, and they were working through problems, the more time they spent in mathematics, their reading scores and their behavioral skills both were better. So know that that's the impact of math that mathematics has. So one of the things we kind of need to understand is that to be fluent in math, we often think of fluency as, hang on a second, I keep going off screen, as being fast and accurate. You know, time tests are big, being done quickly. We have standardized tests. Everything is to be fast and accurate. When mathematics really is about thinking and strategizing. So in order to get our kids into those great STEM careers that we put a lot of money into getting kids aware of these STEM careers, we really have to have an idea of the mathematics that involves to do those STEM careers. And a lot of it involves the problem solving aspect of it. So we really want to start kids in that understanding of problem solving really at a young age. So I saw this meme on social media one time, and I really liked it because it showed the importance of reading 20 minutes a day. And it was really put out by the Reading Society or the Library Society on trying to get kids to read more. And it shows that if you do 20 minutes of reading, that your word usage increases, the more vocabularies that you have increases. And so it increases substantially based on how much time you spend reading. Well, the same can be applied to mathematics. So the spending a minute a day or so in addition to what you're doing in class in mathematics really gets you to understand just simple numeracy. Doing more than that 5 minutes a day might get you better at algorithms and your math facts, but it's not until you do more time in mathematics do you really get those good problem solving and mathematical thinkers. So think about that. That math is as important as reading in the time that you spend in it. So in a couple of researches to kind of back up is that in 2011, they were looking at 20,000 kindergartners. And like I had mentioned this one before, they found that the more time in math actually increased the math scores, their higher reading scores, and then developed better social skills. So that was a well-established research out of 20,000 kindergartners. And then there is also research that in 2012 looked at 32 states plus the District of Columbia and found that in order to prove third grade literacy was really more time spent in mathematics is what brought up the reading scores also, because math is such an important thinking skill. So we really need to provide opportunities where we can combine reading and mathematics, and sort of kids can grow from that. So 21st century skills, they did a survey amongst Fortune 500 companies and what were the skills that businesses were looking for. And they all, well, that kind of came out funny, all were dealing with communication, collaboration, critical thinking, and creativity. And those are the skills they were looking at. None of them necessarily says reading or mathematics, which we know that that's implied, but they also need these additional skills in order to be fluent in getting career opportunities in the future. And so we need to understand that math really is a superpower in all this. So my job is to really, what I've found to be my mission is to make people enthusiastic about mathematics. Now, like I said earlier on, you don't have to be actually good in mathematics. If you're enthusiastic about mathematics, you can bring your kids up to the levels that you want to bring them to high levels of mathematics, just through your enthusiasm for the subject matter. So know that you can fake it to get kids to make it. So some of the important points on timelines with kids, and know that at a very young age, kids form their opinions on mathematics. So by third grade, students, and this is, third grade are young kids that are already determining if they're good or bad in math. And that's due to time tests and really emphasis on math fact memorization. And so these kids at that young of an age are deciding if they're good or bad in mathematics, which we really need to change, because that's such a young age to determine if they're good. And then the other is by fifth grade, students have already started to form what track they'll be taking, because fractions become such an important point, and fractions are all the basis of learning algebra. So with them getting a firm understanding of fractions, which happens a lot in fifth grade, it happens in third, fourth, and then real emphasis on it in fifth grade, that we really need to get kids feeling comfortable with it, that they can, and understanding fractions that they can expand on into higher level mathematics. And then one of the things they found amongst minority students is that the difference in their standardized testing wasn't so much, the difference wasn't in the answers they got correct, because they were pretty similar in that. The difference was the number of questions that were not answered. And they found that minority students were much more willing to leave a question blank than to fill it in. So we really need to encourage kids to feel confident in mathematics that they'll fill in an answer. So we really want them, even if they don't know it, come up, answer something, because then it shows that they're at least trying. Giving nothing shows nothing. So we really want kids to be able to really try to come up with answers on tests. So as I mentioned before, I'm a big advocate that mathematics should be a team sport. Kids should always be doing mathematics in a group, regardless of what it is, I really think kids should be working together in mathematics and really talking amongst themselves, because that's going to develop that deeper understanding of math vocabulary, math concepts, and really help them bring up their self-esteem in mathematics when they're working with others. So it gets them to try, learn, and then think about what they're learning. So it really gets kids to really try and persevere more when they're in groups. So developing that culture in class, I'm going to have some questions to ask you. So you can respond in the chat box or visually, however you want to do it. But how much time should a teacher be talking in class? Should they be talking about 30% of the time or 70% of the time? I see one hand up. Good. I see 30. So if we want kids to become really good problem solvers and be working towards that in class, the teacher should be only talking about 30% of the time. The kids should be spending the other, that 70% of the time talking amongst themselves and asking questions and getting clarification. If the teacher is talking more, they're just giving information and they're not really seeing if that information is being retained. It's through the interactions that you see kids doing that you'll see if things are being retained. So next one, what type of questions to ask? Should you ask more open-ended questions or yes, no questions? So that one might be kind of obvious from my earlier question on how much time teachers should talk. But yes, the questions should be open-ended. They should be encouraging kids to give a response to what you're asking. A yes, no is just going to end it right there and you don't go any further. So we want to make sure we ask open-ended questions. And then how should a teacher respond to an answer? Should they say, oh, that's right, or that's wrong? Or should they ask the student to expand and clarify, regardless of the outcome? So yes, so we do want teachers to expand and clarify. If you just say that's wrong, they're not really going to learn anything from it. So we want to be able, even if the question is wrong, we want kids to clarify how they got that answer. We want kids to explain to us their thinking and their processing so that we can help them obtain the right answer. And then who should you call on when you're working with kids in a group? The first person with their hand up, or wait and do a random selection? Yes, so we should wait and do a random selection. And that being that the first person with their hand up, if you respond to that person, everybody else has stopped thinking. So if I was here and I called on Catherine to give me an answer, and Catherine said, I think it's wait and do a random selection, everybody else would say, all right, that's answer's done and we're done. So we want to make sure that that we aren't just calling on the first person who raises their hand. And I see Paula said maybe not even random, but somebody who doesn't normally raise their hand or puts their hand up. And I'll say that is true, but we want to make sure that the person who is going to get a response is somebody who's ready to respond. So making sure that the child, because I had a very nervous daughter, and if she was asked to respond to a question that she didn't raise her hand on, she would break down and crying, actually. So we want to make sure that we know our students and how they will respond when called on, when they are not ready to respond as well. So yes. And then how to respond to errors. That's wrong next, or have them once again explain their reasoning to the answers. And I think I already answered this one earlier. So we want them to explain their reasoning. And I'm going to say, we learn from our mistakes. Granted, some of us have to make our mistakes multiple times before we ever learn from them. But if we know the answer and we've already given the answer, we already knew it. So if somebody, let's say I'm the first person with my hand up and I've been called and I give the answer, I already knew the answer. I didn't have to think about it. We want to really have those that make errors and have to think about it, is that they're going to learn from that. So we want to make sure that the kids understand the importance of having an error, because they do learn from those errors, and that errors are perfectly fine and they should be rewarded and praised for trying. Okay, so let's talk a little bit before we get into our problem solving, is setting up groups for solving problems. So like I said, I really like these activities, problem solving, to be group activities, but setting up a group has a lot of dynamics to it. So first is establish your goal. What is the goal that you're trying to get to? Is it just the answer, their explanation of how they got there? What is your goal? And next, keep the groups between 4 and 5 students. It could be 3, 4, or 5, depending on the activity, but you want to keep them small because you want it to be intimate. You want them to be able to communicate together and feel safe in the group. And then establish flexible group norms. So know that off the fly, you might have to change rules and change strategies because things come up. So making sure everybody knows that things are flexible, that nothing's set in stone. And then build trust and openness so that kids feel that they're confident and they are safe within their space of working on the problems. And then create group roles. So the group roles could be, who's going to write things down, to who's going to be the one that facilitates the conversation, make sure everybody has a turn. If there's going to be any testing or writing, there's lots of group roles depending on the problem that you can have each child do. And then grouping, I'm going to give you just some information on grouping so that when you're setting up groups with kids, you can think about these when you're setting up groups. So if you allow students to have student choice, meaning they get to pick what kids they're going to be with, there's pros and cons to all these different ones. So the pros is that they're positive attitudes because they like each other normally. So, and they tend, because they like each other, to have higher outcomes. And it also takes less planning. If you let the kids pick, you don't have to do any planning. The cons are that it's not as diverse, because kids will stick with who they know and will stick with that. And then some kids might not be selected. And those kids who know each other can get off task because they might chat about other things. So there are cons to that one as well. So random grouping, pros and cons also. Pros are, once again, it takes less planning because you're just going to draw sticks or do something that is random grouped. You have better diversity because it's just randomly grouped, and builds better communication skills because you're learning how to communicate with kids that you don't normally talk with. The cons is that you could have negative attitudes based on the selection, that kids not be happy with who they were with. And so that might cause low group cohesion. So there's those cons on it. Then the last is the educator selects based on academics or based on how well the student performs. And the pros are, it's organized based on their needs and improves the depth of learning. The cons is it widens the achievement gap because those that are doing well are going to be doing well. Those that need more help are going to need more help. So you're not bringing kids up to levels, you're keeping them at their levels. And then it does involve more planning because you have to figure out where each kid is at, and it can include labeling as well. Regardless if you label them themselves, kids know and they will label themselves. So just those pros and cons on group selections. So problem solving strategies. There's different strategies, and we're going to address each one of these in a problem that you're going to help solve. So there's draw a picture, there's act it out, there's guess and check, there's look for patterns, work backwards, and make a list or a graph. There's other ones also, but these are the ones we're going to address today. So first off, I think it's really important that kids have a math journal. So this journal that I have pictured there is one of the best journals I know of, because I like it a lot because it has tabs to it. So it's easy to make because you're just going to cut paper to different sizes and then just fold it. And then you have a nice little front and back to it. And they can add their information onto the flip, if you can see that. So they can just add their information on that section. And you can add as many sections as you want into it. But it's just a nice way to have a really compact little math vocabulary journal. You could have one that's just strictly vocabulary journal. You can have one that has strategies to it. There's different ones that you can do, but it's really a great tool for kids to have, and kids should have this tool. Oh, I have somebody, how do you group during Corona? So this is a difficult question because every state has different rules on grouping and different ways that they do it. So I know in the state of California, kids are masked. They have hand sanitizers. They sit at a table, but they're a certain distance apart when they're at the table. Different states are doing different things. So it's a really hard question to answer. I mean, it's a good question to ask. It's a hard question to answer because each state has different strategies. Some states have no protocols in place, and other states have really strict ones. I'd say for California, kids are masked and they're sitting around the same table. They're just distance apart. And then the idea is that they all, after whatever activity they're doing, is they wash their hands and they move on. And they try to keep kids in the same group throughout the day. And then they switch groups on a not so often time period. So like those kids are with that group of kids for a week. And that all depends on what school and what teacher they have. But some teachers are doing, these kids are always grouped together for that week. And then the next time they'll switch them up. We have been suggested to use stable order groups. I don't know what a stable order group is. Catherine, can you explain what that is?
It's basically what you described. Same students stay together for tracing purposes. So that stable order, and they've actually, for us, it's 6 to 8 weeks just because of trends and cycles. So that's just heterogeneous stable order groups is our from our district is a suggestion.
Oh, good. Thank you for that information. Yeah, thank you for that. All right, so journals are very important, and having kids have that with them at all times. Like I said, you could have ones that are based on strategies, one that are vocabulary, and then there's different strategies you can include in them. So I'm going to talk a little bit about this last strategy on this one that's called cubes. Now, I'm a big proponent of mnemonics. I'm dyslexic, and so I use mnemonics all the time to remember how to do steps, especially, for driving. I think of my right-hand buddy, so I know that that's my right side. When I'm in a car, I come up with mnemonics to memorize math facts. I use mnemonics a lot. This mnemonic works if the kids can see it. The problem with the mnemonic is it does the C-U-B-E-S, C-U-B-E-S, the C, which means circle. I don't know what I'm supposed to circle unless I saw the rest of that problem, because that's like, if you think of the mnemonic, dirty monkeys, smell bad. Is that what it is? Anyhow, that one works a little bit better because each one of those letters means a step I'm just to take. This one, the meaning, there's more to it. So it's not the best for people like me, but it is a mnemonic that can work for some kids and when they're organizing their problem solving strategies. Okay, so our first problem, here's our first one. We're going to get right into it. This is draw a picture. So I am a tremendously visual person. Anything I do, I have to make a visual representation of it. I have done this for years, all through college, graduate school. If I'm presented with a problem, I have to make a picture and image for it. And I think that needs to be encouraged more with kids, because I think we do it a lot with our primary grades, but don't do it as much with our upper primary and our middle school grades, allowing them to draw pictures. We tend to think of it as being childish and stop doing it. I really think we need to encourage drawing pictures more. So in this case, here's our problem. A group of students is standing in a circle. Every student faces someone across the circle. The student count off in order, starting with number 1. Student number 2 stands across from student 10. How many students are in the circle? So one of the things I encourage kids to do when they see this type of story problem, and especially I'm mentioning the fact that I'm dyslexic a lot, because I'm just showing you strategies that work for me, is I need to take out the important information and kind of post it out in bullet points so that I know what I'm looking for. So I know student 2 stands across from student 10, so I can draw that visually. And it starts on number 1. So I know there's number 1. So from there, can you figure out how many students are in the circle? And if you have an answer, you can post it, but can you figure out how many students are in the circle? If you have an answer, you can put it in chat. So this is a great one you can do. You can start this off with younger kids in 2nd grade, but you can definitely make this more complicated for your upper elementary students. And it's a great one for them to sit down in a group and talk about and discuss, how do you think this is? Let's draw a picture to represent this, and so on. So any other answers? All right, I'm giving you about 15 more seconds. We've got a nice array of answers here. All right, so here we go. So we know that 2 is opposite of 10. So 1 is going to be opposite of 9, right? Because that's the one before it. So they're going to be facing 9. So then how many are there? Here's the visual of it. There'll be 16. So if you had gotten 16, you had it right. Did you draw a picture, or did you realize that if 1 and 9 went together, that the 8 would be then the last one, and the opposite of that one would be 16? Or did you have to draw pictures? I honestly couldn't figure out without drawing a picture. So you could just put a little thumbs up if you drew a picture. Good. All right. So this is a great one. Like I said, 10 and 2 and double it because it was half. And did that work out for you, Kelsey? Okay. All right. Next problem. So this is a draw picture. So with problem solving, you really need to break down strategies with kids and show them different strategies, and then they can determine what strategies work best for them. But for me, like I said, I draw pictures all the time. All right, next problem is going to be an acted out. So you don't actually have to get up, and Kelsey's all excited about this one. That's her forte. But for this one's acted out. So I'm going to show you a card. And acted out doesn't have to actually be that you are actually acting it out. It could be you're modeling it with something. So this one's often manipulatives are really good for it. So I'm going to show you this card. I'm then going to take it away. And I would have kids rebuild what they saw. But instead of you guys rebuilding it, can you tell me how many blocks were in that image? Any guesses? Can we see it again? Yes, I'll show it for a very short time. I'm going to count to 10. All right. And this one, the kids love doing this one. I love doing this one with them too, because they will build it out what they think they saw. Some kids are very visual, in which they can keep an image in their minds. Like I'm visual in that I have to draw it out so I can see it. But some people can actually see that image in their heads and think about it. I can't see that image in my head at all. So just be aware of that when you're working with kids, especially on mental math. Some people like myself, I can't hold a number in my head in order to add another number to it. I have to write it out. So some kids really cannot do mentally because they just aren't capable of seeing something in their mind's eye. So I'm going back. It was 11. So some of you get that one right. Yep. All right. I'm going to do another one. All right. Ready? All right, how many? More than 12. All right, we'll show it one more time. like I said, I love doing this one with kids. They really actually have a better attention span than adults on focusing on things that they really like, which blocks are one of them, so they can see that. So let's see what we had. 17. So if you had seen 5, you'd figure 5 underneath it and then had to add the other ones. So they are a little bit, these ones are a little more tricky because you guys are obviously not of child's, a 7-year-old's, but you can do these with different patterns. And you can actually show it to them visually, but it's really good spatial understanding. They start to realize that there is something underneath something else. So they have to, even though they can't see it, they're problem solving and they're trying to determine what's there. So when you're having kids talk about this and communicate amongst themselves about it, they're going to be expressing that type of information with each other. Like, oh, I saw 5 blocks. Well, there had to be blocks underneath it because what's holding it up type of conversation that's happening with kids. So it's a really good problem solving activity that kids will be discussing when they're doing it together. All right, next one. So here's a game, and the name of the game is Petals Around the Rose. The name is important. 5 dice are rolled, and I will tell you how many petals appear. Your task is to figure out my rule for determining the number of petals. All right, so here's my first roll, and there's 6 petals. All right, next one. I'm going to show you another one. Sorry, I was answering somebody on chat. Okay, here's my next grouping. 12. Any idea? The petals around the rose. Read the directions one more time. All right, here's another one. 8. Okay, I'm going to give you another clue. You've got to tell me what is the rule that makes these numbers. So here's 1, and I have 4. What's the rule? So not all math problems involve numbers. Some of them are strategies in which you have to figure out what it is they're asking. And last one, I had somebody who come up with an answer, see if it applies to this last one too. If your hypothesis is right, your guess on the rule is right. So there is explanations in the chat box which are correct. So the dot, if you have a dot in the middle, that's your rose, the center of the rose, and the petals are around it. So only the dice 3s and 5s can have petals around them. So if you see, it has to have that center dot, or that center pip, and then the other ones are around it. So this is a good one for kids to do, that you can do with kids and just have them try to come up with what is the rule, and they can be talking amongst themselves, collaborating and communicating and trying to come up with the solution based on that. So that's a good one for guess and check, because you're guessing on what you think it is. You got to check it against the next problem and come up with a solution. All right, so one of the reasons I'm kind of showing these off the cuff ones is that we often think of problem solving as being a math problem in which they have to solve, that you have to add together. But math is all about problem solving in lots of different ways. So this one is looking for patterns. And this is actually, you see these patterns here are an old Japanese system for poetry that was done in the early 1000 AD that they discovered. So this is a pattern that had been created with Japanese poets is what you call poet writer. And this is the system they came up with. So if you look at this one, At night, I go on board and say, good night to all my friends on shore. I shut my eyes and sail away and see and hear no more. This is a part of a poem out of My Bed is a Boat by Robert Louis Stevenson. So looking at the patterns over on the side, those red markings, which one do you think goes along with that poem? And if you guess that, why? Why does it go along with that? So this is, even though we're reading poetry, poetry is always mathematical in its rhyming. So it all goes together. Poems and music are all mathematical. So it's really neat for kids to understand that those type of things go along with it. So yes. So the first and third lines rhyme, the second and fourth lines rhyme. So number 9 is the example for that. All right, well, I'm going to show you another poem. Whose woods these are, I think I know. His house is in the village, though. He will not see me stopping here to watch his woods fill up with snow. Stopping by the Woods on a Snowy Evening by Robert Frost. So which one does that go along with? So 12 was our guess and 12 is correct. So that one it is going along with that. The third line has no rhyming words to it. All right, last poem. Said the pelican to the elephant, I think we should marry, I do, because there's no name that rhymes with me and no one else rhymes with you. And that's The Romance by Shel Silverstein. I have guesses of 6. And 6 it is, because the only 2 rhyming are the do and you, the second and fourth lines. So now looking at this, can you guess what symbol is missing in number 7? So I don't have a symbol in number 7. So now looking at these patterns, what do you think falls there? Connecting 1 and 2. Any guesses? All right, I'll show you this one. So it is the last 2 lines, last 3 and 4 are rhyming. So this is a great way to kind of get kids to understand that looking for patterns isn't just in numbers, it's in rhyme, it's in music, it's in other things. So kids get to see the expanse that math has in other subject areas and other things. And you could do this with songs to lyrics, you could do it with different anything, poetry, different things that they might be interested in. All right, working backwards was our next one. So this one, working backwards, is a strategy for some problems. And kids really need to be taught on how to work backwards, because there is a thought process involved in working backwards that is contrary to what they're seeing. So I want you to look at this problem a little bit and see if you can't come up with what that start number is. And I like doing a lot of these different problems. They can be made shorter, they can be made longer, they can have division and multiplication in it so that it can get more complicated, but it's a really good strategy of giving kids a work backwards problem like this and then show them another one that's in a story format, in a written format, so that they can see how it applies. So any guesses? Got a couple people. All right, I'm going to start showing the answer. So this one, I like this process because it gets kids thinking about how you get to an answer. So when they're working in groups, they really start to have a communication and collaboration about how is it that I got to 17? And you should know that to get to 17, if I added 3 to get to 17, I'm going to have to subtract 3 to get to that number in the green. So that's 14. And then I'm going to have to add the 8 to get the 22. And then I'm going to have to add the 9 to get to 31. I'm then going to have to subtract the 5 to get to 26. And then add that 7 for 33. So this, like I said, this is a great one to do with kids to understand the fundamentals of working backwards, because you have to be able to think of those inverse operations in order to go backwards on it. So it's a great strategy for kids to use. All right, last one we're going to do together. I'm going to get off of this and I'm going to use a whiteboard. I'm not going to present on this anymore, but it's going to be on logic and reasoning and making a list. I'm going to do both of these together. So the game I'm going to play is called Digit Place, and you're going to guess my number. Let me write down a number, so I have a number handy, but understand that digit means a digit, which is 0, 1, 2, 3, 4, 5, 6, 7, and 8. Those are digits. A place means that it's in the ones place, tens place, or hundreds place, or thousands place. And if I say it's in the right place, that means you've got the right digit in the right place. All right, I'll repeat these rules, but I'm going to stop sharing this one, and I'm going to go back to sharing, and I'm going to get a whiteboard here. So hang on one second. All right, move people around here. Hang on one second. I want to make sure I see chat boxes and people visually. So hang on. All right. So I am thinking of a number. I actually wrote it down beside me. It's 4 numbers. It's 4 digits. So it's in the thousands place. There is no repeat digits. So I'm not going to have 2 ones or 2 whatever. It's all going to be individually different digits. So I just need somebody to tell me a number, and I'm going to write it down on the board. Oh, it's like mastermind, exactly. All right, so your number is 1, 2, 3, 4. All right, that was Paula's guess. So, oh, I had Catherine. I'm going to start with 1, 2, 3, 4 because that's what I saw first. Sorry, Catherine. So out of 1, 2, 3, 4, I'm going to tell you, you have 1 that's in the right place. I'm going to put a P here. 1 that's in the right place, and 1 that's the right digit. I should have changed the color of my pen here, but this is the number. And you have 1 that's in the right place and 1 in the right digit. Hang on a second. Let me get, where's mine? Oh, here we go. Hang on. Oops. I'll waste my little. Sorry. My thing is on a different page. Anyhow, it's Hangman for next guess. So anybody want to guess a new number? So I have 1 in the right place and 1 that's right digit. I need another guess. Okay, Kath. I'm not going to use Catherine's number because she did one before we had already started guessing. So I'm going to go with one positive directions, and I have a 4, a 5, a 7, and a 6. All right, so this 4, 5, 7, 6 has 0 things. There's nothing in the right place or in the right. There's no number there that's right. All right, so wait. All right, I have the first one was 1, 2, 3, 9. 1, 2, 3, 9. All right, this one has 1, that's the right digit. There we go. And I have 2 in the right place. So 2 numbers are right, 1 number is in the wrong place, and 1 number's not in there at all. Oh, can you not see the whiteboard? Kelsey, can you not see the whiteboard? Oh, what happened to my whiteboard? Just a second. Let me go back to sharing.
I can see a white blank screen, but I can't see you writing the numbers on it.
Huh. Hang
Yeah,
on.
you're sharing your screen. You can stop sharing and then share again, see if that works.
Okay, I'm going to see if that works. Stop sharing. Hopefully I didn't take out my writing here. Hang on. All right, can you see it?
Yes.
Okay. So 1 digit's right and 2 are in the right place. And we're making a list and doing logic and reasoning. And if I was doing this with the kids, I'd have them all chatting together and collaborating together. All right. So I have 1, 3, 8, 9. All right, 1, 3, 8, 9. I have 1 in the right place and 1 that's the right digit. So 2 numbers are incorrect. Anybody have another guess? All right, 2, I'm going to do 2, 0, 3, 9. All right, so this one has 2, oh, nope, 3 in the right, or that are right digits. Sorry, there's my 3. And 1 that's in the right place. So you got all the numbers right, just not in the right order. 1's in the right order. 2309. We're going to be dropped off here in a second. So I'm going to stop and give you the answer before we. So the answer was 3209. So good guessing, everybody. You guys got very close. But that's a great one to get kids to understand how to make lists and why lists are important, and really gets them engaged in that process. So that is, I'm going to stop sharing. Take any questions that you might have. And you can unmute yourself to ask them. But if you have any questions, that is the end of my presentation. And thank you for attending. I hope you learned something. This should all be video
It is
recorded.
Yes.
So yeah.
Yes. It is live streamed. It will be on our YouTube page. So check that out. Mary, that was an absolutely phenomenal presentation. And as you can all see, it got you guys engaged. So I'm sure young people will absolutely have a ball with this. I hope everyone learned effective strategies to make everyone a math champion. We thank you so much for joining us on this afternoon. Please follow us on our social media to keep up from stuff from Mary, which we'll share, other resources, which we'll share. And we hope to see you in Orlando this upcoming new year. Mary will be there. We're in person in Orlando, Florida, February 23rd to the 26th. And we'll see you next Wednesday at 3 p.m.
Thank you.